Alkaline water. You've seen it everywhere, right? It comes with these huge promises for a better, healthier life. But here's the big question. Is it a genuine health miracle, or is it just a really well-marketed myth? So we're going to dig into the science, the claims, and all the controversies to see what we can figure out.
Yeah, you've definitely seen the hype. I mean, it's got celebrity endorsements, those fancy bottles are all over the grocery store, but what does the science actually have to say about it? That's exactly what we're here to unpack in this explainer.
And the promises, wow, they are big, aren't they? We're talking about claims of better hydration, detoxing your body, even anti-aging and cancer prevention. You know, it almost sounds a little too good to be true, which is precisely why we need to take a much closer look at the facts.
Okay, first up, let's talk about the alkaline water buzz. We've got to start by understanding exactly why there's so much hype in the first place. So what are we even talking about here? Well, at its core, the definition is actually pretty simple. Alkaline water is just water with a higher pH level than the regular stuff that comes out of your tap. It usually lands somewhere between 8 and 10 on the pH scale.
Now to really get this, we need to do a quick pH lesson. Don't worry, I promise this will be quick and painless, but it's totally essential if we're going to understand the whole picture.
All right, so think of the pH scale like a ruler for acidity. It goes from 0, which is super acidic, all the way up to 14, which is super alkaline. Right in the middle is 7, and that's neutral. Your normal tap water, it hangs out right around that neutral 7 mark. The alkaline water we're talking about gets pushed further up that scale, typically into that 8 to 10 range.
And this is where the whole argument gets way more interesting. One source we looked at makes a pretty bold claim. It says the pH number itself isn't actually the most important part. Instead, it argues that how you get that high pH is what really matters. Let's unpack that idea.
This brings us to a really key point our source is trying to make. Not all alkaline is created equal. It basically separates all alkaline water into two completely different categories, the artificial kind versus the natural kind.
Now check this out. The source article points to a warning it says comes from the World Health Organization and the US EPA that you shouldn't regularly drink water with a pH above 9.5. That's a pretty serious claim, right? And the source uses this to build its case against certain ways of making water alkaline.
So the source draws this really sharp line in the sand between two types of alkaline water. On one side, you have what it calls artificial electrolysis, which is a process that uses electricity to make the water alkaline. And on the other side, you have natural alkalinity, which is what happens when spring water picks up its pH from all the minerals in the earth. This distinction is the absolute cornerstone of the source's whole argument.
And according to the article, those artificial ionizers, well, they might come with some potential risks. It suggests that the metal plates inside them can break down over time, possibly leaking trace metals into the water. It also says the pH levels can be all over the place, and that the process might even strip out essential minerals that you'd actually want to keep.
So after laying out this whole case against those electrical ionizers, the source then flips the script and presents its own approach as the perfect solution. Let's take a look at the alternative it's proposing.
The company behind our source article, which is called TipaTech, lays out its mineral-based system. It makes a point of highlighting that it uses NSF-certified materials, enriches the water with magnesium, and creates something it calls a negative ORP. So what is ORP? It stands for oxidation reduction potential, and a negative number is linked to antioxidant effects. The key part of their claim is that they do all this naturally, with no electricity and no added chemicals.
And to really drive its point home, the source gives us this direct head-to-head comparison. You can see the table here pits the electrical method against its own mineral-based system on a few key points. The risk of metals getting into the water, having NSF safety certification, and how much energy it uses. This is the heart of their marketing argument.
And here's another thing. Instead of chasing those super high pH numbers, the source recommends a more balanced range, from 6.5 to 9.5. They argue that this is much closer to what you'd find in healthy, natural spring water, and it also lines up better with those safety guidelines they mentioned earlier.
Okay, let's pull all of this together. After all that, what is the final verdict? What's the key takeaway from the source's entire argument?
So what's the bottom line, at least from this source's perspective? Well, it boils down to this simple checklist for what it considers to be healthy water. It argues you should look for 4 things: that it meets NSF safety standards, that it has a balanced pH, that it gives you natural antioxidant effects, and that it contains essential minerals like magnesium. And of course, this checklist leads you right back to the product they're selling. So we just walked through one company's very specific, very detailed argument for its way of doing alkaline water. And it's a pretty compelling story, for sure. But it also shines a light on a much bigger challenge for all of us. In a world that is just flooded with wellness trends, how do we get good at separating a company's marketing message from the actual science? That, I think, is the real question to think about. Thanks for tuning in.